Andrea, let's start on our hike. What do you think we could find here?
Hey Gabby, look what I found. What is this amazing rock? How was it made?
You know what? I think I remember Ivano talking about it in class. It's a pegmatite.
Magnetic, magma, granite asteroids, magma chamber, pegmatite, lava, igneous, liquidus, solidus, crystallization, cannibalism, amphibian.
Oh yeah, I remember now. Pegmatite is an igneous rock. Igneous rocks are formed deep within the earth. We live on a thin piece of crust approximately 50 kilometers thick. Beneath the crust is the mantle and the core made of solid metal. The lithosphere is made up of crust and the upper mantle. Beneath the lithosphere is the asthenosphere, consisting of the lower mantle. The asthenosphere is viscous and allows the rigid lithosphere to move on top of it.
Igneous rocks are formed deep within the lithosphere, but where exactly are they formed?
Yeah, I remember. It's formed in a magma chamber, kind of like a...
Like a cauldron?
Yeah, like a witch's cauldron.
Cool!
Rocks surrounding the magma chamber are often heated and melted into the magma, which is called cannibalism.
Rocks come in three states, similar to phases of water going from solid ice to liquid water and gas steam. For rocks, these are solid, crystals on liquid, and liquid. Each phase is separated from one another by boundaries.
At lower temperatures, the mantle rocks inside the cauldron are all in the solid state. To melt the rocks, we must change phases and cross the solidus boundary by adding water, decreasing pressure or depth, or increasing temperature. At a depth of 100 kilometers, rocks are approximately 1500 degrees Celsius. The temperature needs to be increased to 1600 degrees Celsius, or depth decreased to 75 kilometers. Adding water to the cauldron changes the solidus boundary.
Right! As the temperature turns up, the solid rock will start melting. Liquidus, liquidus, melt the rock! Rocks are made of minerals. Minerals are naturally occurring solid inorganic substances with a fixed internal structure and chemical composition. Minerals within a rock have different melting points. Different melting points means that minerals with the lower melting points, well, they melt first, creating magma!
Minerals in igneous rocks are made of silica but differ in their structure. Minerals with complex structures have the lowest melting points, such as amphibole. Minerals with simple structures, such as olivine, have the highest melting points.
At this point, the melt in the chamber differs in composition from the remainder of the rock due to partial melting.
Okay, I see. But what happens when the temperature cools?
Well, the liquid can begin to form crystals. Which minerals crystallize depends on the composition of magma and physical factors such as temperature and pressure.
The crystals that form first are the minerals that have the highest melting points and simplest structures,
Such as olivine in our cauldron.
leaving minerals with the lowest melting points and complex structures in the melt, such as amphibole.
The crystals settle out, or the melt rises too fast, separating the two in the cauldron.
This process, called fractional crystallization, causes the melt to evolve towards more silica-rich composition, like what is found in pegmatite. Gosh, we've learned so much! So back to our discovery.
The large crystals in this pegmatite indicate cooling occurs over a long period of time and stable temperature. Cool!
Let's catch up with the group.
Goodbye, my pretties, my precious pegmatite.